Welcome to Brain Vision.
So here they're trying to find the resultant acceleration after the uniform solid disk has turned through 0.1 revolutions. So we can first write down our givens. We have a radius of this uniform solid disk, 0.400 meters. We have a mass of 30 kilograms. Guys. We also have a theta t of 1.10 radians per second, and this will be times time. And this will be plus 6.30 radians per second squared times t squared. Let's first try to find the angular acceleration. It's simply derivative of the angular displacement. So this will be 1.10 radians per second plus 12.60 radians per second squared times t. And then we can say that the alpha t will simply be the derivative of the angular velocity, and this will be 12.60 radians per second squared. So at this point, we can say that the change in theta is 0.100 revolutions. We also know that there's 2 pi radians per 1 revolution. So this is going to be 0.628 radians. And at this point, we can find the tangential acceleration. This is simply going to be r alpha. So this would be 0.4 times 12.6, or 5.04 meters per second squared. We also need to find a time, so we can set this delta theta equal to the equation for theta, and we can have 0.628 equals 1.1 t plus 6.3 t squared, and we can use a TI-84, TI-85, TI-89, whichever one you would like, in order to solve for t, and t equals 0.24 seconds. And then we're going to find the angular velocity at t equals 0.24 seconds. This is going to be equal to 1.1 plus 12.6 times 0.24. And this is going to be equal to 4.124 radians per second. At this point, we can find the radial acceleration and find that this is going to be equal to r omega squared. So this will be 0.4 times 4.124 squared, and this is going to be equal to 6.803 meters per second squared. At this point, a resultant is going to be equal to a tangential squared plus the square root of a tangential squared plus a radial squared. And we find that this is going to be equal to 5.04 squared plus 6.803 squared. And this is going to be equal to 8.46 meters per second squared. So this would be your answer. This would be the resultant acceleration after an angular displacement of 0.1 revolutions. That is the end of the solution. Thank you for watching.